Hi, good morning, guys. So today our agenda is what we are going to discuss is that how 22 by 7 is a rational number. So this is our uh, main question, which we will try to answer. How 22 by 7 is a rational number. So before going to answer that, um, let us talk about number. How many types of numbers we deal with? So number, if you go and think, so number is of two types. First one is imaginary, right? And second one is real. So real number, imaginary we means it's a square root of minus something which we don't deal with now. So real number can be further categorized into two categories. In our day-to-day life, we deal with real numbers mostly. So it is rational, okay, and other number is irrational. In our day-to-day life, we deal with real numbers. So that's why it's called real numbers. And real number is of two types: rational and irrational. So what is rational numbers? We will first understand what is rational numbers. Rational numbers can be understood in two ways, right? That way one. What is way one? Way one is that can it be expressed in the form of p by q? Can it be expressed in the form of p by q, where where p q where p q is integer, okay, and divisor, which is q in this case, is not equal to 0. Divisor is not equal to 0. So p by q, a number which can be written in the form of p by q, where the divisor, that means q, is not equal to 0, it's called rational number. That is one way to to express rational way. Okay, what is the number two for? What is way two? As per way two, it talks about, it differentiates rational or irrational, right, in terms of their decimal expansion. In terms of decimal expansion, what are rational numbers? In terms of decimal expansion, in terms of decimal expansion, okay, in terms of decimal expansion, a rational number is either terminating, is either terminating, okay, either terminating or non-terminating recurring, non-terminating or non-terminating recurring, okay, recurring or repeating, whatever you say, recurring, I will just put here equal to or repeating. In terms of decimal expansion, you can say a rational number is either terminating or it is non-terminating but repeating. So this is way 2. In this way also, in terms of decimal expansion, this is the definition of rational number. In terms of fraction, this is the definition of rational number. That it can be represented in the form of p by q, where p and q are integers. We denote integers by z, and q is not equal to 0. Okay. So irrational numbers, if time allows, I will discuss that too. Okay, I think I should discuss that as well. So what are the examples of rational number by way 1. What are the examples of rational numbers by way 2? We will see that. Okay. So what do you think about 22 by 7? 22 by 7 is a rational number because it satisfies both the ways. From both the ways, 22 by 7 can be proved as a rational number. Let me tell you how. From way it is quite clear. It is quite clear that it is represented in the form of P by Q, where P is 22 and divisor that is Q is 7, which is not equal to 0. So as per way 1 definition, as per the definition of rational number, in the fractional form, 22 by 7 is satisfies the criteria of being rational number, right? So let us check in terms of decimal expansion, right? So way 1, you can say with way 1, yes, it is a rational number, right? In terms of way 2, is it a rational number? Okay. In terms of way 2, we will try to find out the value of 22 by 7. Let us try to find out what is the value of 22 by 7. 22 by 7, if you go and do, you will find it 3.14. Just a moment, let me use calculator basically. Let me be precise. 22 by 7. 3.142857. 2857, right? Again 142857, and this pattern keeps on repeating. So if you observe it carefully, what is getting repeated? This much 142857, 142857, and so on, right? So it's what kind of decimal expansion it is, right? What kind of decimal expansion it is? Is it terminating? Is it terminating? No, it is not terminating. Then is it non-terminating? Yes. In non-terminating, what type of non-terminating decimal expansion it is? It is non-terminating recurring. It is non-terminating repeating. It's this much pattern is getting repeated, right? Is getting repeated infinite number of times, right? So in that case, you can write 22 by 7 as equal to 3.142857. You can put a bar here and you can say this much pattern is getting repeated, right? So it satisfies that it is non-terminating recurring. So from both way 1 and way 2, we can prove easily that 22 by 7 is a rational number, right? And it is quite different from pi. So we will talk about pi as well, right? So what is pi? Here I will talk. So for pi, we will first discuss about irrational number. Okay? We are done with rational number, and we gave an example of 22 by 7. That 22 by 7 is a rational number, right? So now let us talk about irrational numbers. So irrational numbers can also be defined in two ways. Okay? Irrational numbers can also be defined in two ways. Way 1 says that you cannot express in the form of fraction. That means you cannot write it in the form of P by Q. You cannot write it in this form, P by Q, where Q is not equal to 0. We cannot write a irrational number in the fractional form, right? So that is one way to identify a rational number. And what way 2? Way 2 says in terms of decimal expansion. In terms of decimal expansion, right? Irrational number is non-terminating, right? it's non-terminating and non-repeating, non-terminating, non-recurring, non-recurring, yeah, or non-repeating means, non-recurring means it's a non-repeating. It's simple. It's non-repeating. Okay. So, have you ever tried knowing the value, exact value of pi? Go and what is pi? First of all, let's discuss that. Okay. Pi is the circumference of a circle. Circumference. You take circumference of a circle and you divide the circumference by its diameter. That is called pi. So pi is when you go and calculate the value of pi, when you go and find out the value of pi, this you can get on Google also. So you will see that pattern is not getting repeated. No pattern is getting repeated. I will try to find out the value of pi. Just a moment, please. Value of pi, it says, is approximately 3.14. 3.14, okay, 15926, 15926, right, and then 53589, 53589, and so on. With the help of the supercomputers, mathematicians and scientific community have calculated the value of pi up to, as per my memory, they have calculated up to the value, up to the decimal places 1.3 billion decimal places. Or it is, I think it is, yeah, it is 1.3 billion decimal places, and they have found no string, no decimal pattern getting repeated, no decimal. So it is. So on that basis, we say that it is not terminating and non-recurring because no decimal pattern is getting repeated. See here, 14159, okay, 14159, 2653589, and keep on getting different numbers, right? So there is no pattern identified till now which is getting repeated. So it is treated as non-terminating and non-recurring, which fulfills the definition of irrational number. So by way 1, is it a rational number? Is it an irrational number? Sorry. Is it an irrational number? Yes. By way 2, is it an irrational number? Yes. By way 2 also it is an irrational number. So what is the difference between pi and 22 by 7? You can directly say that 22 by 7 pi. 22 by 7 is a rational number, right? 22 by 7 is a rational number and pi is irrational number, okay? Pi is irrational. 22 by 7 and pi are not same thing, I repeat. Because 22 by 7 is a rational number and pi is irrational number. So that's all for today. Thank you.